Hello everyone and welcome to this webinar from NGINX and Red Hat on a deep dive for automating the application and security pipeline. I would like to introduce our presenters, Mark Boddington from NGINX, part of F5, and Victor DaCosta from Red Hat, who will take you through this webinar. Please note, a recorded version of the webinar will be available after the event. If you have any questions, please submit them via the chat at the bottom right-hand corner of the screen, and we will be answering these at the end. I would now like to hand you over to our presenters, Mark and Victor.
Thank you, Anya. Welcome, everyone. My name is Mark. I'm an NGINX solutions engineer, and I'll be kicking off this morning. I'm joined by Victor DaCosta from Red Hat as well. So today's agenda, we're going to quickly do a recap of the automation webinar that we ran a little while ago, which was basically covering automation and security from a high-level business perspective. Then we're going to talk about automating using Ansible tools, along with NGINX Controller and NGINX Plus. We'll then go on to automating hybrid cloud application delivery, and we'll finish off with a demo followed by Q&A. So just to recap what we talked about in the last webinar, we see, this is what we see in the industry very much, traditional applications built on a three-tier monolithic type architecture still account for around 60% of production workloads today. But as companies go through digital transformation and modernization, they start moving towards microservices type environment, but it's not a rip and replace, a jump straight to that environment. We see hybrid deployments initially, where you modernize the application by bringing on new parts of the application as microservices, and they sit around the edge of the traditional monolithic application, and that's accounting for 30%. And then we see 10% in more greenfield sites. So where you have a brand new application that's starting off, we see the deployment as very much being focused around microservices, containerization, and quite often deployments into Kubernetes or OpenShift environments. So there are many reasons why people are moving towards these dynamic modern applications. Cost, time to market, reducing how long it takes to develop new features and functions is a benefit of using the microservices type architecture. So rather than having to upgrade an entire monolithic application with hundreds of different features and functions, you can upgrade just small parts of it independently. And as people move, we see they're moving from three-tier architectures to microservices, away from complex protocols such as SOAP-based APIs to lightweight REST and JSON ones. Deployments are no longer persistent, so we're not looking after feeding and watering servers, but we're deploying ephemeral containers and even functions as a service. And as we move down this route, we bring in infrastructure as code and automation with continuous delivery, and that's driven very much by emerging DevOps culture. So with modern apps and even traditional apps, we have various ways to help you automate the deployment in those environments using a combination of Red Hat's Ansible Automation Platform, along with NGINX Controller, which is our API-driven, application-centric control plane for managing NGINX deployments. And that's very much where NGINX Plus is deployed in a infrastructure as a service or even a monolithic environment. But it can also manage ephemeral instances into OpenShift container platform. And we also provide Kubernetes ingress controller functionality for both OpenShift and also Kubernetes. So with that, I'll hand over to Victor to talk to you a little bit more about the Red Hat automation platform. Over to you.
Hello, everyone. Thank you, Mark, and thank you, everyone, for joining today's session. So I'm Victor da Costa. I'm part of Red Hat and technical business development for Ansible in particular and automation. So Mark, if we move on to the next slide. Thank you. So what is exactly the Red Hat Ansible Automation Platform? Most of you are used to the tower, right? Ansible Tower, which is one piece of the entire platform that we provide. And as part of the platform, what we have is what you already know, meaning the Ansible and the playbooks and all of that being managed with the piece that we will schedule and run the entire automation. But on top of that, you also get the cloud services that are provided as part of the platform to have more visibility about the automation workload that you schedule and that and you run. And not only that, but also a lot of certified content that will give you the confidence to run the automation and to rely on different content that has been certified and co-supported between us and the partner. And that's exactly the case for NGINX content as well. So if we move on, Mark. So what is exactly the overall architecture of the platform that we are talking about is that you have different components that are on premises and others that are hosted in the cloud, and they both together will provide the elements that you need to run your automation with confidence. And not only that, but also all the different content that will provide with certified partners, regardless if we are talking about automation of traditional, let's say, infrastructure and operating system, but also cloud automation, network automation, security, and so on and so forth. And all of those then can be used by the different type of personas that you have in your organization and have them working together in order to have the automation at scale in organization. So you probably have personas that will be in charge of creating content. Here is mainly creating playbooks or creating plugins and so on and so forth. You have the operators that will use and consume, and you also have the different domain experts that will work together and that will provide the piece of automation required to deliver services that at the end of the day will be consumed by all the different users within the organization, even non, let's say, IT users or standard business users that will only want to have an application deployed in a hybrid cloud context. All of that is for sure developed with the community, with the open source community and everyone involved in the project and in the different content that are co-developed with partners. So if we move on, Mark. It's also important to highlight that we have more than 90 certified platforms, and here is applied to all the domains. So here we do not have the entire list for sure, but we can highlight the main ones that we often see in the field as well when it comes to automation of infrastructure or cloud, network, and security. And today we'll go more deep dive in the automation with NGINX in the context of application delivered in a hybrid cloud. We move on, Mark. Thank you. So for those who don't know what exactly is Ansible Playbook, it's made of mainly three components, right? So basically in the playbook, you describe in the sequence of all the activities that you need to automate something. So this will create, you can have a single one or you can have a different place describing all the different actions that you want to automate. And that's something that we'll also, if we have time, go deeper in during this session. Then you have the models, which are basically the piece that will interact with the endpoints. For example, here we'll see models that will interact with the NGINX controller, but that is also the case when you need to interact with the cloud providers or when you need to interact with network device and so on. And the plugins will allow you to extend those capabilities to also send some requests to some external system and to grab some additional information when needed. For example, most of the time, you probably need to request a token, let's say, for an external system in order to do all the authentication, or you may need to do some web service request to some system to get some other piece of data and so on. And all of those, for sure, you can extend, and you can also create your own plugins if needed in the context of your organization. If we move on, Mark. Next, we talk a lot about the collections that as the new way of package, let's say, and delivered content. And that's exactly the movement that we are now. And that's also the case for the content that we'll see during today's session that applies to NGINX and the controller. Here is just an example showing how collections are structured, right? So basically you can package inside of collection, or you can consume existing collection that will provide not only the models that you need to interact with those different devices and systems, but also roles that will encapsulate, let's say, the different actions and activities that you need to do. And you can also rely on existing playbooks that are being provided by those partners. And this is what we'll also see today as part of the session, that we as NGINX, they are already providing some playbooks in order to do different actions and activities. We go more deeper, if, as I said, if we have time during today's session. And here in this example, we are calling for a role that will install NGINX, and that then after that we are calling for another role that will install app protect for NGINX. Then I guess we are more keen to go in the demo and spend more time on that, so I will hand over back to Mark.
Thanks, Victor. So we're almost at the demo. Just going to recap a little bit about how NGINX controller and NGINX Plus ingress controller inside OpenShift can be used with the Red Hat Automation Platform. So first of all, a little bit about controller. Controller provides you enterprise automation for NGINX Plus. It has a declarative API that you can integrate with Ansible to automate your delivery of services into NGINX. It provides a high level abstraction for both application delivery, load balancing, and also API management use cases. It collects metrics as well as can forward those metrics to ecosystem partners. And it can provide a place for managing NGINX App Protect, so WAF policies for deployment into your deployments. We also have role-based access control to enable you to secure and provide self-service to your users, and we'll look at RBAC quite extensively in the demo, because it's one of the things that help you or enable you to give self-service to the many different teams that might need to deploy applications in either your traditional infrastructure, whether that's on-prem or in the cloud, or container-based services. We'll also look at Kubernetes automation. So Ansible can deploy and work with cloud providers and set up operating systems, install packages, as Victor went through, but it also through collections can interface with Kubernetes directly. So we'll be looking at not only deploying a traditional load balancer, but also deploying an ingress controller with Ansible automation. The nice thing about the ingress controller with NGINX is it's built to run inside Kubernetes or OpenShift. It's fully managed through that Kubernetes API. And all configuration comes from Kubernetes as the source of truth. We'll be configuring the kick using the Kubernetes core collection from Ansible. The kit integrates with Prometheus and Grafana and Open Tracing, so the standard DevOps toolkit within that Kubernetes environment. And you can also deploy WAF here as well. So NGINX App Protect can go anywhere NGINX can go. So whether that's running as a VM in infrastructure, running on a bare metal instance in a data center, or running as an ingress controller inside OpenShift. And again, RBAC comes in time and time again because it's what enables you to secure these deployments and say who can or cannot make changes to a particular environment. And in the Kubernetes space, we fully integrate with Kubernetes role-based access control, and we do that by the use of custom resource definitions. And that may need a little bit more explanation, so that's what we're going to talk about next. So just briefly, if we look at the Kubernetes or control plane, and this is, in all Kubernetes, whether that's a Kubernetes from a cloud provider or whether it's an OpenShift deployment, at the center of that you have the Kubernetes API server, and that API server is where you have defined all of the resource types that Kubernetes can manage for you. So that's deployments, services, scheduled jobs, ingress. So all of these different elements are defined in the API server. And then when you create a resource, when you post a resource to that API server, a controller of some kind picks up that resource and deploys it. So typically that's the Kube controller manager. But some resources in public cloud environments are picked up by a cloud controller manager. So being able to interface with things like public cloud key vaults and stuff like that. So this this is essentially how Kubernetes works for all of its elements. You have this control loop. You have a controller which is in charge of implementing changes as they occur, and controllers target particular deployments. So the ingress controller is quite a well-known resource in Kubernetes, and so you have an ingress resource which is defined in the API, and when you create a resource using that definition, the Kubernetes API will accept it based on the details you've provided, and then an ingress controller will pick it up and actually deploy it. But if we focus in on ingress specifically, there is a problem, particularly when it comes to automating deployments of ingress and securing the different elements that ingress is providing. So Kubernetes ingress provides SSL termination. It provides routing based on host header and paths. And that's pretty much it. That is all that is defined within the spec itself. Everything else you might want to do with a layer 7 traffic manager or ADC is applied through annotations and config maps. And these both have issues. Annotations are not validated by the API. So if you make a mistake in an annotation, it doesn't get picked up by Kubernetes. Your change will be accepted by Kubernetes. And then perhaps later on, your ingress controller will throw an error and fail. Right, so it's very difficult to pick up these problems during the automation, during the pipeline, because Kubernetes doesn't know very much about ingress. That is to say, there isn't very much to know about ingress. So because of that, at NGINX, we provide support for ingress, but we also build out our own custom resources. So we extend the API by creating additional resources, and then we make those available for managing your load balancing. So we can route based on many different things, not just host and path, but we can do it on cookies, headers, methods, etc. We support additional protocols. We can deploy WAF, as I mentioned earlier, and implement layer 7 traffic policies like rate limiting, access control lists, doing traffic splitting and circuit breaker patterns as well. And we don't do this in just a single resource. We actually do it across a number of resources. So we have resources for security policies that protect, resources for rate shaping and ACLs, resources for the actual publishing of a service, resources for routing of the application as well. And this means that you get role-based access control again for all of these different parts of deploying that application. And we're going to show you a little bit of that now. So before we get into the demo, I'm just going to explain briefly what we have set up. We have an Ansible tower deployment. That is, you can see down here in the bottom right, and that is going to be basically managing all of our deployments. So it's going to be talking to NGINX controller using a controller collection that we publish. It's also going to be talking to NGINX instances, again using the controller collection, but it's going to connect to NGINX running as a load balancer in front of Kubernetes to deploy agents. And then it's going to actually be managing the ingress controllers as well as the applications by talking to the Kubernetes API server. So we're going to automate all of this, so both traditional load balancer deployment as well as new modern ingress controllers, all through a single Ansible tower deployment. So with that, I'm going to stop sharing that for a moment and start sharing. This one. So, okay, so hopefully you can see my browser window.
Yes, we do.
Yeah, excellent. Okay, so first thing I'm going to do is I'm going to log in to Ansible Tower as my admin user, and this is the admin. So this is full rights to the system. When we log in, the first thing we see is the Tower dashboard, so we can see how many jobs I've executed over the past few days, how many passed, how many failed, that sort of thing. We can also see those jobs in detail under the Jobs tab, and we can see the scheduled jobs. So Ansible can schedule jobs to run at particular times. I don't really have anything particularly scheduled apart from general cleanup activity, which is in there by default. The only thing I've added is an inventory sync, and we'll talk a little bit more about inventories in a few minutes. Before we get into an inventory though, let's talk about how Ansible actually brings in a project that it needs to automate. So you have projects in Ansible Tower, and these can either be manually defined, they can be pulled in from tar archives, for instance. But in this case, we're actually linking directly to a GitHub repository. And we can see that GitHub repository here. So I'm literally loading this in from GitHub, it's a public repo. And then and inside here, I have a bunch of playbooks and also a requirements file. So the requirements file basically tells Ansible which collections I'm going to be using. And in this case, you can see I'm using the NGINX controller collection as well as the NGINX core collection. I'm using Azure as well. So I'm going to be talking to as resources in Azure. All of these NGINX instances and even the Kubernetes deployment is running in Azure. And I also have Kubernetes core so that I can talk to the Kubernetes API. So we have our project, and this can be set up to automatically sync or sync whenever we run a new job. So that's in there. Within the environment, we're also obviously setting up role-based access control. So we determine who's allowed to access this project. And I have 2 additional users that I'm going to switch to in a little while. I have a Kubernetes operator called Kate, and I have a DevOps guy called Dave, and they'll both be deploying different elements. Linked to this project, we have some job templates, and the job templates allow you to actually execute those playbooks. But before we look at the template, let's have a look at the other elements we have under resources. We have credentials. So credentials are can link to either external credential management systems, so we can link to HashiVault or even Azure Cloud Vault or VMware. solutions. There's lots of different credential types you can create. In here, I have several. So I've actually created an SSL certificate credential. I have credentials for connecting to controller as the different users. So the role-based access control we're using in Tower. We're also using role-based access control within controller and in Kubernetes to secure who can do what in terms of deploying solutions. I have a Docker registry here as well for connecting my Kubernetes environment to my container registry and various other elements. And like the Git and like the Git repo, the project, each of these, so if I look at controller dev, for instance, this is one of my developer users, and this is RBAC enabled as well. So only Dave can use this credential. I'm giving Dave read permission as well as use, but it could be that you only want him to be able to use it, but not actually see what the credential is, in which case you can remove that read permission. We have credentials, we have projects, and the other thing you need with Ansible is an inventory. And an inventory is the list of hosts we're going to be controlling. So in this case, I've got a local inventory, which is just a default one, and I have this Azure UK inventory. Now, this Azure UK inventory is actually being sourced from Microsoft Resource Manager. So what happens is every 5 minutes or so, my Tower reaches out to the Azure API and collects a load of hosts. And I have a host filter here, so I'm looking for one starting MB with control, NIM, or NGINX followed by a number. And I'm creating groups from those. So I'm creating a controller group, an NGINX group, and an instance manager group. If I go back, we can see the host that's picking up. So these are all imported from Azure, and then I put them into groups. So controller, NGINX, and NIM. And these groups are how I reference them in the playbooks. So in a moment, I'm going to run a setup playbook to set up environments in controller. And you can see I'm referencing the controller hosts within this playbook. And this is going to be using the NGINX collection. I'm going to be authenticating, and the authentication details here come from Tower through a credential. And once I've authenticated, I'm then going to create a development, production, and Kubernetes environment. And after that, I'm going to create users and roles as well.
Mark, just a quick comment in terms of credentials that you mentioned during this session is that it can also be integrated with external Vault. So even if here we are using local credentials that are registered and protected inside of the platform and Tower, you could also integrate that with an external vaulting system in a case where you have more secure standard in your organization.
Yeah, absolutely. Thanks for that, Victor. So what I'm going to do now is I'm going to actually connect. I'm going to run my first template, and we're going to be setting up some environments and some users and some groups around the controller. So if I switch to my controller tab quickly, just to show you, this is a fresh controller. There's no roles. These are default admin, user, and guest, and no users currently. So the roles in controller give you access to environments, and I don't have any of those either. So what we're going to do is we're going to execute a playbook, and we're going to first of all set up the environments and then create the roles to go with those environments. And you can see this is how a job or a task looks in Ansible, in Ansible Tower. So we have a name, description, the inventory we're going to use, and that's that Azure UK that we're accessing. We have some credentials as well. So we have an SSH key in order for us to be able to SSH onto the controller. And we have this controller admin credential, which is so it can log in as the controller admin. And this one's going to set up the environment. So this is linked. You can see the playbook set up envs, and this is linked to this playbook. Right, so this is the playbook that Tower is going to execute for us, and it's going to bring in credentials to log in, to authenticate, to log into controller by using this controller admin credential. So I could run this directly, and that will run just one job. But instead, the other thing you can do in Tower is you can link jobs together in workflows. So I have this setup controller, which is a workflow, and it's going to actually run all of those jobs for me. So it's going to set up the environments, and then it's going to set up the roles and the users. And in parallel to that, it's going to connect to my NGINX instances, of which I have 2, and it's going to get those to register with controller as well.
I guess this is a good timing. Sorry to interrupt you, Mark, because we got a question that was asking about what would Ansible send to NGINX load balancer, right?
Yeah. So
if the controller is the only source of truth.
So yeah, so controller is designed to be driven through its API. It's API first, so you can drive controller from from any number of different pipeline tooling. Ansible Tower is a great option. So in this scenario, the source of truth is really our Git repo, right? So we've got our source code in Git with our playbooks, and those those playbooks hold the config. They are the source of truth. When Ansible is used to automate deployment of that source of truth, it pushes config to controller. So it does an upsert to controller to bring its current state in line with whatever that new state is that you want. And then controller will then communicate with the NGINX instances that deployment relates to update their configuration to bring it in line with whatever you have in version control. I hope that answers the question. So what I'm going to do now is I'm going to kick off this job. So if I go back to here and just launch it, we'll see it brings up the workflow. And this is how it's going to be deploying. So first of all, we're going to set up the M's. So it's going to be running this playbook. So log in, create these environments. At the same time, we're using this setup NGINX playbook. Again, we're using the controller collection. We're getting our authentication token. But in this environment, we're actually retrieving the agent registration key and then connecting to NGINX and running the install. So yeah, this is the thing that registers that controller.
So I guess
agent with controller. Sorry.
That's also part of the answer, right, for the previous question about what is the role of, let's say, Ansible when the controller is the source of truth, let's say, is to have the end-to-end automation pipeline, right? Meaning
exactly.
Instance registering, configuration of the controller, and so on and so forth. All this.
Exactly. Yeah. So controller won't deploy an NGINX for you. Well, it can actually, but only in some environments. And Ansible can deploy NGINX into more environments than controller can, for instance. So yeah, you'd use, because Ansible can talk to all of these, has all these different modules, all these different collections to integrate with many different services, deploying into VMware, deploying into Azure, AWS, etc. Ansible is a way to bring not only the NGINX stuff, not only automate the NGINX side, but automate deployment of the application itself and everything else that goes to make up the application you're delivering. So that's finished. Just in time, excellent. So we've deployed NGINX, registered it, set up the environment and the users, and we can now see that these 2 NGINXs have popped up. If we look at our platform, we should see we have now some additional roles, SRE, DevOps, and Kubernetes, and also our Kate and Dave users, which we're going to be using from Tower as well. And finally, the services. So we have those environments which role-based access control is giving access to the SRE team to production and to the Kubernetes team to Kubernetes system. So we've deployed that. That's all up and running, and we've now set up our controller. That's great. So we've got the traditional side done. Now let's have a look at Kubernetes. So what we want to do next is actually deploy an ingress controller into Kubernetes. So we have another job for doing that, and I'm going to run this one as admin as well. And once this is done, I'm going to switch to one of the other users to show you how it looks from a different user's point of view. So we're going to be deploying this one, ingress deploy. Now this one's going to be executing this playbook. And again, this is in our Git repo. We have an ingress, and it's going to be running this YAML file. And this basically just imports a number of other playbooks. So it's going to create one to deploy a namespace, deploy some common resources, create the CRDs. So remember I mentioned that in Kubernetes, we do support ingress, but we also support our own custom resources, which give you better control over the configuration. So we create the CRDs, some RBAC service accounts and stuff, and then we're going to deploy an ingress controller. And these are very much using, these aren't using NGINX collections, these are using the Kubernetes core collection of Ansible. So we are literally talking to the Kubernetes API to do all of this side of the thing, this side. So we're deploying, creating the namespace, creating a service account, uploading our Docker registry config. And this is all being interpolated by Tower. So this Docker config comes from that credential. And this is how you link your playbooks with the credentials and other elements and variables and things that you bring in through the Tower templates. So let's kick that off. That's my launch button. So if I launch that, that's going to start deploying stuff for us. While that's running, let's just have a look. If I do kubectl get names.
In the meantime, while it's running, we got another question, which is, does NGINX ingress replace Kubernetes ingress?
Yes, yeah. So with inside Kubernetes, there are various different ingress controllers you can choose from. The CNCF project have kind of a reference implementation, which is based on NGINX. But we build and maintain our own NGINX ingress controllers as well. That's also on GitHub. So this is our ingress controller. This is the one. Yep, this is the one that we're going to be deploying today. I'm using NGINX Plus, but it also supports open source as well. So yeah, you only need one ingress controller. So yes, this would replace that the one that Kubernetes maintained. So that's now deployed, and if I see I did a get namespaces before that was running, and there was no NGINX ingress namespace at the time. Now there is, and if I look inside that namespace, NGINX ingress. Type. You can see we've now got two NGINX ingress controllers running. I'm exposing them on node ports so that I can load balance them to them from that external NGINX deployment. So now that's been deployed and running, I can now start deploying some applications. I've got my load balancer set up, I've got my controller environment ready, and I've got an ingress controller. So what I'm going to do now is I'm going to log out from my admin account, and I'm going to log in as Kate. And Kate is our Kubernetes, on our Kubernetes team. And she has a different view of the world. So admin can see everything. If I log in as Kate, I can only see the things Kate has permission to. And in this environment, the only thing Kate is responsible for is the monitoring of the monitoring system, so Grafana and Prometheus. So I have a number of playbooks, and these all relate to jobs, again, within our Git repo under monitors. So again, a lot of these are, pick one, Prometheus config. A lot of these are using Kubernetes core, and this one's actually taking a manifest file from a manifest folder. So you can define, put definitions directly in Ansible in the playbook, or you can reference existing manifests that you might have used previously. So that last one was used sourcing from a manifest. This one is actually defining the object within the playbook directly. So let's kick that off. So again, I have a workflow template. If I launch this, we'll see what it does. So in this case, we're doing a few more things. We're going to create the monitoring namespace first. Then we're going to upload some config maps for Prometheus and Grafana. Then we're going to deploy the services. And we're going to create a vServer resource, which is a custom resource that the NGINX ingress controller is going to pick up and then make available on its external ports. The one thing we haven't included in this workflow is the job to actually then deploy that into controller. So I will kick that off next once we've deployed this.
So basically, you log in, as Kate. So you relying on, in the meantime while it's running, so you are relying on the role-based access control, right?
That's
At both sides, meaning from the automation and also from the controller and so on.
Yeah, indeed, yeah.
And both you can integrate also with external systems like LDAP.
So yeah, in this demo environment, I'm using local roles and local user databases, but both controller and Ansible can integrate with Active Directory, for example. So you could link them both to an external auth system. And as you said, I'm logged in as Kate. When I look at credentials this time, I have a much shorter list. I can only see the things that Kate is able to access. So Kate can access the key, but her permission is only use. So she can use this SSH key, but she can't see any other information about it. She can't actually see certificates and stuff. So is that finished? So look at our jobs. How are we doing? Still running. So it's created the config. It's now doing the deployment. Actually, while that's running, I can kick off the controller part as well. We're running a bit short on time, so let's just do this. So we've got all of this. So this setup basically executes our Kubernetes services. We have a controller deployment as well. And this is going to execute this 101 gateway. And this one, you can see we're using the SSH credentials again. We have a controller cube credential, and this is going to log in as Kate into controller. And then we have a monitoring certificate that we're going to deploy as well. So if I launch this, and that will then connect to controller. And within the Kubernetes environment, at the moment we have no components or applications deployed. That playbook is going, when it starts, is going to actually deploy a gateway, a component, an application into controller. And we're providing an extra variable this time, NGINX, and that's going to be, if we look at the actual YAML file, we'll see that the instance it's being deployed on is taken from that variable. So it's going to be deployed onto my NGINX 1 instance. So that's running. It's running now, looking good. So under certificates, we probably have a certificate now. So it's uploaded our monitoring certificate. It's creating the gateway for us. It's created a Grafana gateway so that I can now connect to Grafana. And this is now running. I can log in, and you can see I'm on a. So I've logged into Grafana. This is collecting metrics from Prometheus, both running inside that Kubernetes environment. And this is data coming from my ingress controller. So,
Mark, in a case where I had multiple clusters, right, I could consolidate the view of them, all of them, and the applications that are deployed in multiple Kubernetes cluster in different clouds and so on through a single view, right?
So, yes and no. So controller can give you a view from a per instance view and an application and component view and environment view, in fact. So for each of, in each of these elements, I can go in and I can see, I can go and see what is going through each environment. And I picked Azure Dev, which obviously has nothing deployed in it. But you can see it at environment level, you can see it at component or an application level. So depending on how you connect a controller, you get to see different elements of it. So they could be multiple NGINX instances, in multiple different clusters, or it could be in a single cluster. So
but I could rely on the controller as my entry point, let's say.
So controller becomes your central point of managing the config of all of your NGINX instances. The only difference is when they're ingress controllers, because the ingress controllers are designed to be managed through the Kubernetes API, in which case you'd probably use Tower if it was managing your Kubernetes deployments. So in the ingress controller case, Tower would be your central point probably. In the non-ingress controller, you could use controller itself. So that's deployed. Excellent. We've got Grafana. Let me I'll just get a 404 off this because it's not been deployed. We're running really short on time, but let me just kick this off and then we'll go to questions. And maybe we'll come back and see the website afterwards. Launch that. So I'm logging in as a different user. Again, I've got different access, different credentials, so I can see controller dev and controller SRE as this user. So this is one project, and these are my templates. I'm going to run a workflow. This one's a bit different in that it does both Kubernetes and controller, but it does them in parallel. So we're going to create elements on NGINX controller up here, so the gateway is and apps and components and stuff, and at the same time we're going to deploy our WhatCheese namespace, deployment services, and virtual server as well. So while that's running, just really quickly show you again in this component though we're actually deploying NGINX App Protect as well. So we're deploying a WAF, and all of these different resources could be controlled by different users, right? So in that simple demo, I'm creating a WAF policy as well as deploying the WAF policy, but you might have a security user in Tower that has permissions in Kubernetes to define and modify app protect policies, whereas your DevOps user might only just be able to reference the policy but not actually define it. So I'm using app protect policies, I'm using traffic management policies, I'm using virtual server to publish, and in this case publish and route, but down here I have a split responsibility again where I have a virtual server which publishes my API, but I have a virtual server route which manages the internal routing. So again, this could be a permission you give to operations, and this could be a permission you give to the application developer themselves. So it's not quite deployed yet. So that's all finished. That's successful. So hopefully, oh, it's broken. Oh well, never mind. That's broken as well. Never mind. I think we've just about run out of time anyway. So if I stop sharing that, we'll go for some questions.
Yeah, we answered some of the questions when we were going through the demo and the presentation, but I don't know if there is any additional question here.
Okay.
Thanks, Victor. We've just had one or two that just came in, I think, directly in the chat. One was, how do you host or integrate via APIs, Kubernetes microservice to produce the applications, and how many steps are there for the output of the data streams?
So good question. There's I guess that there's various different steps, but some of the steps can be combined into single playbooks. So from a Kubernetes point of view, a service is made up typically of a deployment, which manages So typically you'll create a deployment, and that deployment will create a replica set which manages the pods, and then that you can attach autoscalers and stuff to it, but usually deployment that manages the replica set which manages the pods. So that's one resource you create. Kubernetes handles the rest of it. To make what those pods do available to another microservice or even to an external system, to make it available within Kubernetes, you then create a service which is linked to that deployment. To publish it externally, you'd then create an ingress resource or a load balancer type service, or one of our custom resources, so virtual server or virtual server root, and that gets it essentially available externally from Kubernetes. And then in front of that, you'd often deploy an NGINX or an F5 or a cloud load balancer to manage traffic onto that ingress controller. So there are various steps, but in terms of what Ansible would do, Ansible Tower, in terms of number of templates, you could do it with just one. You can have a template which has a playbook which has lots of different steps and does all of those things for you. So you could end up executing one job, and then all the other stuff happens in the background.
Thank you, Mark. And we have another one. Have you seen any ROI metrics after implementation? And what are the common issues that have come up and how are they resolved?
I think we have a slide for that, don't we? I think the next one was going to talk about ROI. Do you want to talk about this, Victor? I didn't actually look at this.
Yeah, this is something that we put as a backup slide from previous session as well, which highlights some of the return of experience that we had from both sides, from Red Hat and also NGINX, in terms of ROI. So basically here in the right side, you have numbers that are related to the automation, and in the left, you have numbers that are related to NGINX and delivery of container in production, and speed is the key here, mainly when it comes to deploying new applications and being able to have it in production quicker. And what we saw in today's session is exactly all the different pieces needed to do this end-to-end delivery of application, because often people start with a single environment where they deploy and they get things running. That's quick, but when they start to scale what they have done to multiple clouds or to multiple environments, and they also start to have this, to need to have the same process for dev, for test, production, and so on, that's where they start to slow down, and that's the value that we bring both together to this type of scenario.
Cheers.
Okay, I think that's all of the questions that we've been here via the chat. So with that, I would like to thank everyone for their attendance at today's webinar, and also like to thank Mark and Victor for taking us through the presentation. As mentioned previously, a recording of this webinar will be shared after the event, as will the slides that our presenters had today. So we'd like to leave it there. Thank you again for your attendance, and we hope to see you on one of our webinars again shortly.
Thank you, everyone.
Thank you, everyone.